ROSTA rubber suspension system is a torsion elastic spring device based on 4 pretensioned rubber inserts between 2 steel profiles. The vibration joint suspension is designed for pivot motions of max plus minus 30 degrees. The ROSTA spring device combines the functions of a torsional spring, a guide bearing, and a shock absorber. Due to the high hysteresis of the natural rubber inserts, nearly 30% of all impact loads are absorbed internally in the unit. The ROSTA spring device is the ideal unit to compensate the slack on chain drives. During its lifetime, each roller chain is submitted to an average elongation of 2% of the total drive length. Without a continuous compensation of the increasing slack, chain drives start to vibrate and jump and wear out rollers, bearings, and sprocket teeth. A simple, rigid sprocket compensates the slack as long as it is always adjusted according to the degree of chain elongation. Without adjustment, the chain starts to vibrate and favors an early wear out. The rigid sprocket is not the ideal unit for length compensation on chain drives. The ROSTA torsion elastic spring device compensates continuously the increasing slack on a chain drive. The high hysteresis of the natural rubber inserts is absorbing the vibrations of the typical polygonal motions of a roller chain. With the first tensioner setting by a pretension angle of 30 degrees, this automatic unit compensates the full slack during a chain's lifetime. The direct comparison of a chain drive with and without an automatic ROSTA device shows clearly the difference between a smooth running and a whiplash-like hammering when using a rigid system. Rigid systems favor the high wear of all transmission components. Nearly all known chain manufacturers are offering as accessories also chain tensioner systems. The big majority is promoting the automatic ROSTA tensioner device in their catalogs. ROSTA is manufacturing more than 500,000 units per year. One beyond these manufacturers is Fenner Power Transmission.
Welcome back as we next discuss a typical chain tensioner and the general procedures for adjustment. Despite the term tensioner, this ROSTA designed unit is used primarily to absorb vibration and shock loads whilst at the same time maintaining the desired degree of tension. In principle, the device operates via rubber suspension elements housed within the frame. A swinging arm, which supports the slack side of the chain, is mounted in such a way that any deflection via the chain causes it to twist within the rubber elements, which in turn dampen or provide a torsional resistance to the movement. Support for the chain may be effected using a small jockey sprocket or a chain rider, which has a less noisy operation. Tensioning devices are always placed on the slack side of chains and close to the driven sprocket. It must be noted that the suspension arm lies in the same direction as chain movement. Failure to install a tensioner, as described, will result in excessive vibration. During maintenance, The tensioner, by loosening a central mounting screw, can be moved away from the chain. Upon initially adjusting the chain's sag or slack to the recommended amount, we next proceed to set the tensioner, which we shall now demonstrate. Please note that the procedures that we shall demonstrate are for ROSTA models only. Consult the manufacturer's instructions when you encounter other designs or types. The procedure begins as we rotate the main housing, this bringing the jockey wheel into mesh with the chain. We must next observe the angle scale in relation to the arrow here on the arm. Now, by turning the housing, align the arrow to approximately 15 degrees initially. Secure the center screw, then torque it to the specified amount. We have now explained the general procedure for an initial setting of the tensioner. However, we still need to explain 2 points, namely alignment of the jockey and final tension adjusting. First, we consider the jockey wheel alignment, or centralizing to be more specific. A simple lock nut system provides the means to position the jockey wheel anywhere along the threaded support and thus establish a central running position. On the drive assembly, the recommended procedure is to begin by loosening off both lock units. Next, start the unit and allow it to run, whereby the jockey wheel will automatically find its own centralized position, owing to the action of the chain. Stop the unit. When completely at rest, carefully turn the lock nuts up to the sprocket, then secure evenly so as not to shift the alignment. Our next point, final adjustment of the tensioner, is based on the chain's behavior when working under its normal operating condition. Initially, we adjusted the pointer to around 15 degrees, which is an average setting. However, if one notices excessive chain vibration here, between the jockey wheel and the driven wheel, then increase the tensioner's angle until the vibration ceases. Note that we must not increase the angle beyond the 30-degree mark. Naturally, during all adjustment procedures, we must observe the stipulated safety regulations. After the break, we shall discuss lubrication.